Hey guys, so in today's lecture, we are going to discuss a new topic in the chapter of energy efficiency and thermal utilities in system. So, a next system which we are going to discuss, it is heat exchangers. So, as from the name suggests, that a heat exchanger is a device in which the transfer of heat from one medium to another takes place. So, heat exchanger can be classified on different bases, maybe the design, operation, maintenance, and can make the heat exchanger more efficient and minimize the loss of energy. So, we are going to start with pinch analysis. So, how we can uh, save energy in heat exchanger. So, this is the topics which we are going to discuss. It is types, networking, pinch analysis, multiple effect evaporators. So let's start with pinch analysis. So traditionally, there was fixed flow rates and temperatures yielding the heat and mass balanced for the process. So means before it was such that only the fixed flow rates and temperature yielding the heat and mass balanced for the process. Then the design of a heat recovery system is completed. Further, remaining duties are satisfied by the use of utility system. So each of these exercises performed independently of others. So as you can see, this is traditional approach. So design of process, then heat exchange system, and then it is utility system. But in pinch technology approach offers a novel concept to generate minimum energy consumption before heat recovery network design. Before the design, so before you start with the design, you can have the heat recovery uh, you can have the heat recovery input. So heat recovery and utility system constraints are then considered in the design of core processes. So interaction between this heat recovery and utility systems are also considered. So the pinch design will reveal opportunities to modify the core processes to improve the heat integration to improve the heat integration. So the pinch approach is unique because it treats all processes with multiple stream as a single. So all processes considers multiple stream as a single. It is integrated system. This method helps to optimize the heat transfer equipment during the design of the equipment. So this pinch analysis is used to identify the energy cost, heat exchanger network, capital cost, targets for a process, and recognize the pinch point. So the procedure first of all predicts ahead of design. So before you start designing, so it will predict the minimum requirements of an external energy network design that satisfies these targets is synthesized. Finally, the network is optimized by comparing energy cost and capital cost of the network so that the total annual cost is minimized. Thus, the prime objective of pinch analysis is to achieve financial savings by better process heat integration. So, the prime objective of pinch analysis is to achieve financial savings by better process heat integration. What does it mean? Better process heat integration, maximizing process to process heat recovery and reducing the external utility loads. Okay, so now we'll see another example. So so consider this example. This is a simple process where feed stream to a reactor is heated before inlet to a reactor, and the product steam is cooled, and the product stream is to be cooled. The heating and cooling are done by use of two heat exchanger. So that is 1 and 2 respectively. So this is heat exchanger 1 and this is heat exchanger 2. So the TH diagram for the feed system and product stream depicts the hot and cold utility loads where there is no vertical overlap of hot and cold stream profile. So this is temperature versus enthalpy diagram, and there is no overlap. So in this process, as you can see that the feed stream moves from heat exchanger and moves to the reactor and then moves to second heat exchanger and then moves to the final. So here here as you can see that the feed stream from here splits into things from here to here and from feed to forward. So from here it takes the heat and then moves to the reactor. And similarly, after coming out of the reactor, it loses the heat in third heat exchanger and it goes back to the final stage. So this is the process of this heat exchanger. So here as you can see that curves are shifted horizontally towards each other till they are vertically apart by 20 degrees Celsius. So hot stream 1 product, cold stream feed record heat X. So suppose X is the steam, then sorry, so that was another complex heat exchanger. So this is a simple heat exchanger. So here you can see that feed is going from one heat exchanger going to the reactor and coming out from second heat exchanger. So hot stream is the product one and cold stream is the feed. So here as we can see that uh, there is no vertical overlap of hot and cold. So here steam is equal to A and cold water is equal to B. So now we'll see that the diagram which I discussed earlier, and that one heat exchanger is added. So in that diagram, so in this diagram, so in this diagram, an addition of heat exchanger 3 recovers the product heat X to preheat the feed stream. So the steam and cooling water requirements also get reduced by the same amount of X, and the amount heat recovered depends on minimum approach temperature allowed for the new exchanger. So this minimum temperature approach between two cows. So that minimum approach temperature between two cows on the vertical axis is T minimum, and the point where this occurs is defined as pinch. So this is the T minimum and this is called pinch point. So for TH plot, the X amount corresponding to delta T minimum, so the X amount corresponding to the delta T minimum value of 20 degrees Celsius. So increasing T minimum value leads to higher utility requirements and lower area requirements. So this is the example of a heat exchanger and how we can use the pinch analysis. So now we will see another heat exchanger systems, that is evaporator. So multiple effects evaporator. So main factor influencing the economy of an evaporator system is the number of effects. So by increasing the number of effects, the economy of an evaporator system can be increased. The first effect of a multiple effect evaporator is the effect of which the raw stream is fed. So first is the raw stream is fed. So vapors obtained from the first effect act as a heating medium for another effect. So in a single effect evaporator, steam is supplied for heating the feed. So the total heat is not transferred from the steam. So the rest of the heat is wasted. To use the heat efficiently, connections are made so that the vapor from one effect serves the heating medium for the next effect. So as you can see that vapor from one effect helps in heating the steam another effect. This is called nest effect. So the dilute feed enters the first effect, which is partly concentrated. It flows to the second effect for additional concentration, and then to the third effect for final concentration. So the final product is pumped out of the third effect. So in the first effect, a raw steam is fed in which vapor pressure in the evaporator is the highest. So P1, the second effect, has the intermediate. So here P1, the second effect is intermediate vapor pressure. That is P1 is greater than P2 is greater than P3. The pressure gradient is maintained by drawing the vapor through a vacuum pump and considering after the final effect. So depending on the lowering of vapor pressure, as vapor pressure is getting lowered, the boiling point of the liquid of the second and third effect will also be lowered. So here the boiling point will also lower. So in the second effect, vapor from the first effect T1 is heating the feed having temperature T2. So this is heating the feed from temperature T2. So as you can see, it is going from here to here. So the temperature gradient is T1 minus T2, consequently it will be heated. So similar heating also happens in third effect. So what are the methods of feeding? Different methods of feeding. So there are total 4 methods. That is forward feeding, backward feeding, mixed feeding, and parallel feeding. So we will discuss all one by one. So in forward feeding, so the feed enters from the first evaporator. So feed enters from the first evaporator. The product is collected from the last evaporator. So product is collected from the last evaporator. In forward feeding, feed moves from high pressure to low pressure, so that no pumping is required. Pumping is not required. Further, the product is available at low temperature. So on the counterpart, this method is not suitable for cold feed because the steam input in effect 1 raises the temperature of the feed and a small amount of heat is supplied as latent heat of evaporation. Lower amount of vapor in effect 1 produces lower effect in subsequent effect. So the amount vapor produced will be less than the steam supply, hence the overall economy is lower. Now backward feeding. So the feed enters in the last effect. So the feed enters in the last effect and moves towards the first effect. Move towards the first effect. Backward feeding, whereas steam is supplied from the first effect to the last effect. This method is suitable for cold feed because the heat used for the increasing the temperature in the last one is already used for heating 2 times. This will give more economy. This method is suitable for viscous products because highly concentrated product is highest temperature and hence lower viscosity. On the contrary, as feed moves from low pressure to high pressure, pumping is required which consumes huge amount of power. Now mixed feeding. Mixed feeding, the feed enters in intermediate effect, moves forward and backward. Moves forward and backward to effect 1. This permits the final evaporation to be done at highest temperature. Then the last feeding is parallel feeding. So in parallel feeding, feed is given to all the evaporators. So in all the evaporators, feeding is given. Feeding is given to all the evaporators and the product is collected from each evaporator separately. And the product is also collected from each evaporator separately. And this method is used when less concentrated liquid is required to be evaporated. So that is the parallel feeding. So once again I will repeat the feeding. So in forward feeding, it moves from first evaporator to the last evaporator, from high pressure to the low pressure. Then in backward feeding, it moves from last evaporator to the first evaporator, from low pressure to high pressure. So while moving the feed, a large amount of energy is required to pump that feed. Huge power is consumed. Then in mixed feeding, so the feed enters the intermediate effect and moves forward and backward to effect 1. While in parallel feeding, the feed is given to all the evaporators and the product is collected from each evaporator separately. So that is the feeding, how you are feeding the evaporator. So this were the methods of feeding. So this ends the heat exchanger portion, in which there are only two topics, that is pinch analysis and multiple effect evaporators. So in the next lecture we will see waste heat recovery, how we can recover the waste heat. So that will be our next lecture. So thank you very much. and waste heat recovery. After that, we'll see cogeneration, and after that, we'll see our HVAC and refrigeration.